if you have pi over 2 for Wallace is 2 over 1 times 2 over 3 times 4 over 3 times 4 over 5 times 6 over 5 times 6 over 7. I multiply both sides by 4. That will give me a 2 up here. And now I'd like to take the square root. That's going to give me 2 times. All right, the square root. Now, all these things are duplicated. So what it's going to do is go in and pick off just one of each, right? I'm taking the square root of this entire Wallace form. So I'm going to have 2 times 4 times 6 times 8, the evens upstairs. What am I going to have downstairs? The odds, right? But just one of them. Oops, so I write 2. 7 times 9. So the evens upstairs and the odds downstairs. So my claim from massaging Wallace's formula is that. Now evidently, this expression and this expression are the same. How do we see that? Well,
when n is 1.
Well, this would go out. This is the limit as n goes to infinity. So for really, what we have to do is show for really large n, we're picking up all these terms in this pattern. Then as n goes to infinity, the 2 are even. I will get every Wallace term eventually as n goes to infinity. I think if you take one of the n factorials and one of the 2 to the n's, then you can multiply every number in the factorial by a 2 and get all the even numbers upstairs, right? This is what I claim, that these guys upstairs are 2 to the n times n factorial. Limit as n goes to infinity. If I cut this thing off, if I cut it off at n, that's what I have.
Well, yeah, if you factor 2 out of each of those terms, 2, 4, 6, 8.
Yeah, that's 2 to the n times n factorial. All right.
But taking the square root of what you have on top of that, where you have 2 4s, 2 6s, you're only going to take half the factors that are on.
Okay. Well, we agreed that the 2 times 4 times 6 times 8 up to the first n even numbers is 2 to the n times n. What about these? Well, you know, the 2n factorial downstairs is just going to run out like this, right? But the stuff upstairs that's going to kill some things. And what's upstairs is another. You know, I have 2 of these things. One I need for upstairs, and then one I'm going to cancel against this and get just the odd guys, right? Is that true? Oh, look here. There they go again. It's the upstairs guys being removed from 2n factorial downstairs. Right? So if I take 2n factorial and divide by 2 to the n times n factorial, I think I get the odd guys downstairs. 1 times 3 times 5 times 7, right? Which is this. So now I've used everything here. Agreed? Agreed.
It's a little hard to say. Just looking at what you have right above that, I mean, the way I have just the square root function defined in my head, if you have duplicate factors, you don't want to take half of the factors that are there.
Right, that's what I did. When I took the square root, it killed, you know, one of each. Okay, and left me with this. But I also took the square root of 4. Remember, I had taken Wallace's original formula and multiplied by 4 to get the 2 upstairs. So I take the square root of that. That's where the 2 out front comes from, and then I have all that. So I think at this point, I think I have successfully convinced myself, that may or may not be true, I've convinced myself that the square root of 2 pi is equal to 2 that's that 2. Sorry. The square root of 2 pi let me start over here. I'm assuming Wallace's formula. So I am justified in saying the square root of 2 pi is equal to twice two to the 2n, n factorial squared over 2n, the quantity effect. I think that's what I established. All right. And that's in the limit. That's the limit as n goes to infinity, because I need all of Wallace's formula for that. Here, let me write that a little more professionally. Square root of 2 pi, we are saying, is the limit as n goes to infinity of twice 2 to the 2 to the n, n factorial quantity squared over 2n quantity factorial. All right. From Wallace, this apparently is true. We're saying that's true. Our expression, the limit as n goes to infinity of the SNs is the limit as n goes to infinity of square root of 2 over the square root of n times 2 to the 2n, n factorial squared over 2n to quantity factorial. All right, so now we have to merge these and get an expression. So, S. Okay. Remember, the limit as n goes to infinity of Sn is the limit as n goes to infinity of n factorial over the n to the n square root of n e to the minus n. So we can get, if we can get this Sn limit, we'll go back and plug that in. All right, what's this limit? We've discovered that this should be well, this piece here is the square root of 2 pi over 2, right? From this line, from the Wallace line. Square root of 2 pi over 2 is the limit as n goes to infinity of that. So the limit as n goes to infinity of the Sn is the limit as n goes to infinity of square root of 2 times the square root of 2 pi over the square root of n times 2. Jesus. This is where I got lost when I did this. So I just can't get the thing to be just square root of 2 pi.
Well, choose your cancel out. You're just going to be square root.
Well, yeah, there'll be a square root of 2 downstairs. And then there'll be, so it's gonna be
No,
what?
all the twos cancel, isn't it? Because if you had 2 times square root of 2 times square root of 2.
Yeah, right, they're gone. It's
And
this,
so is the 2 on the bottom.
yeah, it looks like that.
Oh, it's